All right, welcome. Today we're going to tackle some pretty tricky programming concepts, but we're going to do it in a really fun way by running our very own virtual pizza shop. So let's fire up those ovens and get right into it. I mean, really, stop and think about it for a second. You probably have your browser open with who knows how many tabs. Maybe you're streaming music and a big file is downloading in the background. How on earth does your computer manage all of that at once without just grinding to a halt? Well, the secret is all in how it handles its tasks. And that's exactly where our pizza shop comes in. Every strategy your computer uses is like a different way of running our kitchen. By the end of this, you'll see that understanding how to make pizza faster is the key to understanding how computers get so much done. Okay, so let's start at the very beginning. Our shop is brand new, a humble start. We've got just one chef, one counter, and one oven. Super simple, right? But even in this tiny setup, there's a secret to being fast. So the first pizza goes into the oven. It's going to take 10 minutes to bake. So what does our chef do? Just stare at the oven door? Take a coffee break? No way. That wasted time is the very first problem we need to solve. And that brings us to our first big idea, asynchronous programming. You see, a smart chef knows that while that pizza is baking, that's a waiting task. They can get started on the next order. Instead of just standing around, they pivot to chopping vegetables. It's all about making sure no time is wasted. So the core idea here is that the computer never gets stuck. While it's waiting for one task to finish, like a file to download, it can switch over to another task. Now, it's not doing two things at the exact same time, but it's using that waiting time productively. This is exactly how a single web server can handle thousands of different user requests without melting down. All right, good news. Word is out and our pizza shop is getting popular. The orders are just flooding in now. Our lone chef can't just work on one pizza at a time anymore, even with their async strategy. They're going to need a new plan for managing a dozen different tickets. This brings us to concurrency. Think of our chef as a master juggler now. They aren't truly making 3 pizzas at the exact same instant. Instead, what they're doing is switching between them incredibly fast. They'll roll the dough for pizza A, spread some sauce on B, add cheese to C, and then jump right back to A. It creates this amazing illusion that everything is happening at once and progress is being made on all the orders. Now, it's really important to remember, the key here is that illusion of doing things at the same time. It's all about rapid task switching. So where our asynchronous chef only switched tasks during a waiting period, our concurrent chef is actively juggling multiple in-progress orders. But, and this is a big but, at any given nanosecond, our single chef, our single CPU core, is still only doing one thing. Okay, the evening rush is here, and just juggling isn't enough anymore. We need to do more, and we need to do it faster. So the owner has a big decision to make. Do we hire more chefs, or do we give our one chef a superpower? This choice perfectly explains our next two concepts. So let's check out the first option, multiprocessing. This is pretty simple. We hire 2 more chefs, and we build them their own fully separate kitchens. Each one has their own oven, their own counter, their own ingredients. They work completely independently and don't get in each other's way. This means 3 pizzas are being made truly at the exact same time. But what about that other option? That's multi-threading. Here, instead of hiring new chefs, our original chef magically sprouts 4 extra arms. Now they can roll dough and chop vegetables at the exact same moment. But, and this is key, it's all still one chef, sharing one brain and one kitchen space. Okay, let's put these two side by side to really get it. Multiprocessing is like having multiple independent chefs, each in their own kitchen, no interference. Multi-threading is like one chef with many hands. They're very powerful, but since they're all sharing one kitchen, or in computer terms, one memory space, they have to coordinate carefully. That coordination creates a little bit of overhead, a tiny processing cost just to manage the shared work so the hands don't get in each other's way. Well, business is absolutely booming, and we just got a legendary order, a single party-sized 10-foot wide pizza. One chef can't handle this alone, not even a chef with extra hands. We're going to need a whole new level of teamwork. And this brings us to parallelism. This is a whole new ballgame. It's not about different chefs on different pizzas. It's about all of our chefs working on the exact same giant pizza at the exact same time. One chef is spreading the sauce, another follows right behind with cheese, and a third is putting on the toppings. They've broken down one massive job into smaller parts and are tackling it all at once. So you see, parallelism is really all about divide and conquer. It's the best way to take one enormous problem, break it into smaller pieces, and have multiple workers solve them all at once. So while multiprocessing has many chefs on different pizzas, parallelism has many chefs on the same pizza. The best real-world example of this is a graphics card, a GPU, which has thousands of tiny cores all working in parallel to draw the millions of pixels on your screen. All right, we've seen all the strategies our little pizza shop can use. We've gone from one hardworking chef to a whole team working on a giant pizza. But let's get to the question that everybody's asking. Which one of these methods is the undisputed king of speed? Let's line them all up and see who gets the trophy for the fastest pizza delivery. And here it is, in first place, taking the gold, is parallelism. Nothing beats true teamwork on a single goal. Right behind it is multiprocessing. Separate chefs in separate kitchens are incredibly fast. Multi-threading is powerful, but it's slowed down just a little by that coordination overhead. And finally, asynchronous and concurrency, while super clever, are still limited by having just one main worker. But here's the most important takeaway of all. Fastest isn't always best. Context is everything. If your main task involves a lot of waiting, like fetching data from a slow network, an asynchronous approach will feel much faster because it's not wasting any time. A whole team of parallel chefs would just be standing around waiting for the oven. So the real question isn't which method is fastest, but rather, which is the right method for the job at hand.